In this video we're going to combine a resistor and a diode in a circuit. I'm sure it's going to work great. Okay, I've made the simplest circuit including a diode that I can think of. It's just a voltage source, a resistor, and a diode. I'd like you to take a minute and solve this circuit by finding ID and VD, which will definitely go smoothly and not reveal any complications. Okay, I'll show my solution. We start by noting that the diode voltage is just a resistor drop below the voltage source. Then we substitute the diode equation for ID and rearrange a bit. Then we throw our hands up in the air because x plus e to the x is a transcendental equation with no algebraic solution. So this means that we're potentially in big trouble. We can't even solve the simplest nonlinear circuit that we can build. And if we can't solve the simplest one, then what are we going to do? I'm going to reflect that question back at you. I'd like you to write down some ways to solve the resistor-diode circuit. I came up with sort of 4 broad categories of solutions when I did this exercise. The first one I came up with was using computers. Computers love doing the repetitive math to solve transcendental equations, so great, let's let them do that. We even have fancy simulators that make it simple to put circuit components into a computer. However, we don't actually want computers to be our first choice. Though they're great at solving circuits, our value added as circuit designers is understanding what's going on inside of a circuit, which computers don't have a way of representing just yet. Fortunately for us, doing brute force searches over the circuit design space is implausible. It's just too computationally expensive. So the insight that we bring as circuit designers is crucial to building successful circuits. So never forget that your value as a circuit designer is understanding what's going on, and if you find that you're just like tweaking the simulation to get something to work, then it's worth taking a step back and trying to reassess how things work rather than just kind of spinning on minor adjustments over and over again. Graphical solution methods are kind of the opposite of computer methods in some ways. They're great for humans to pick up intuition, but they won't give us particularly accurate answers. We can also make simple approximations of the diode curve that make math much easier. And finally, we're going to learn about a really cool technique that lets us examine small deviations of the voltages and currents from like a known fixed point of voltage and current values. This technique is called small signal modeling, and it relies on linearizing circuit elements using a Taylor series. We'll reuse it over and over again this semester. So in summary, the resistor-diode circuit is transcendental, and we'll learn about 4 alternative solution methods in these videos. Computers, which we're going to do last because we want our design insight to come before we simulate things. Graphical methods, approximations, and linearization.